Everyone, so I hope you're doing okay. In this video, we're going to talk about the indoles. Now, this is the structure of indole. We are going to talk about these indoles on two separate videos. In this video, we are going to talk about the synthesis. Now, when we look at the synthesis, there are two main methods that we can synthesize the particular indole molecules. Now, the first one is the Fischer Indole synthesis. And the second one is the Fischer synthesis. I'm sorry if I am pronouncing these words incorrectly. Synthesis. We are going to talk about both of these mechanisms. Now, first, let's look at the Fischer synthesis. Okay, now, let's say we have this molecule. We're going to start this synthesis through this one. We have the benzene ring, and then what we are going to do is we are going to add a ketone. Let's say like this, R1, and we have the carbonyl-carbon, and then we have R2. I hope the reaction between a carbonyl-carbon and this amine is similar to you. The product would be like this. If you have no idea about these two reactions, I will go through it again. But first, let me give you the product. This is the product from this reaction. Here we have the nitrogen and double bonded to this carbon, R2, R1. Okay, like this. Okay, let me go through this reaction. So basically, in this reaction, if I number this carbon chain 1 and 2, this is the number 2 position and this is the number 1 position. What happens is H2O molecule, one water molecule will be removed when this nitrogen atom bonded with this particular carbon. If I take a, let's say, amine like this, and let's take a ketone like this, okay, the reaction mechanism would it would be like this. You know, this carbon over here, it's an electrophilic, like it has lower electron density. Since this oxygen has high electronegativity, it will pull out the electrons from this carbon, and that will create a electron deficient area. When this nitrogen sees this electron deficiency area, you know, the nitrogens have a lone pair. This lone pair can donate its electron density towards this carbon. Now what happens is we will have a structure like this. Here we have the oxygen. Now with this attack, with this donation, you know, this carbon will get destabilized because it has too much electron density. So it will break one of the carbon bonds with the oxygen. Now this oxygen will have a negative charge, and here we have the nitrogen with hydrogen and another hydrogen, and let's take this as R. Now what happens is this one over here. Now you will see that this nitrogen has a positive charge. You can see 1, 2, 3, 4 bonds is being formed from the nitrogen. So it will form a positive charge. Due to this, one of the hydrogen of the nitrogen atom will transfer towards this oxygen atom. So we will have OH, we will have nitrogen, hydrogen, and R. So we will have the lone pair. And then in the presence of acidic medium, so I will take the new page. So in the presence of acidic medium, one of the lone pairs on oxygen will donate its electron density towards one proton, and here we will have OH2 plus, and our nitrogen stays the same. Now you can see the oxygen is on a positive charge, so it will do a certain reaction to go off from this particular structure. This nitrogen can donate its electron density towards here, and that will result in breaking this bond. Now here we have double bonded N H. So here I have done a small mistake. As you can see, there's a R group here, so I forgot to mention the R group. Here we have the R group here. Here we have a positive charge. Now the water molecule has removed. Here we have the water molecule. Now as the last step, what happens is one of the lone pairs on the oxygen will again attack this hydrogen, and nitrogen will regain its neutral form by taking the electrons from the hydrogen bond. The result is this one. So basically this ion is a little bit important. This is called iminium ion. Okay, so this is basically the reaction. Sorry, iminium. Sorry. Iminium ion. This is the iminium ion. This is basically the reaction what happens over here. The same reaction happens in this particular case. So let me erase this one, so we can continue with our mechanism. Now what happens is at tautomerism, if you are familiar with the term tautomerism, it's basically the same thing, right? It's the same thing. This one here the double bond over here will transfer to this position, the adjacent position, and two hydrogens will come to the nitrogen. So here's the structure we have after the tautomerism. Sorry. Same benzene structure. With here we have the NH. Here we have NH2. Here we have the second carbon here. This is the second carbon, and a double bond here, right? And here we have the R1. R2 is in the same position. Now here we will have a positive charge on the nitrogen. Then a cyclization would happen here. This comes here, this goes here, and this bond over here, it breaks over here. So the result would be like this. Here we have the benzene ring, and a new bond is formed between this carbon and this carbon. Okay, so this bond is being broken. Here we have H2 double bonded, and here we have the R2. So here I have done a small mistake. There's the no bond here, right? Because there's a double bond here. Now what happens is there's a hydrogen on this position. This hydrogen will be removed by taking these electrons to form a new double bond between these two carbons, and the aromaticity in this ring will regain. Due to this reform, this bond will here, it will transfer to this position. Sorry, yeah. Now what happens is this bond over here, look at this one over here, it will go and attack to a proton. Now our result would be like this. benzene ring over here, it has regained its aromaticity, so it may become more stable. And there is no other. Yes, okay, here this is the one we have. So don't forget there's a positive charge over here. There's a positive charge over here. Now what happens is, look at this. This nitrogen, it will pull electron towards itself. So this carbon becomes electron deficient. This lone pair will go and attack here. So one of the bonds can come back to the nitrogen to neutralize the positive charge. So final structure would be like, this is the benzene ring, nothing changes here. Now here remember we have an N and two hydrogens, and a new bond is being formed between here, and there's another NH2 like this. So you can see this nitrogen over here, it has become electron deficient, so there's a positive charge is being formed on this nitrogen. Now what happens is the hydrogen transfer. One of the hydrogens on this nitrogen will move towards this nitrogen. So we will have the structure like this. Now as for the last step, if you take this carbon over here, 1, 2, 3 bonds are visible, and also there's a hydrogen over here. So this hydrogen will release as proton to form a double bond between this carbon and this carbon, which will result in breaking this bond and removing this molecule as ammonia. So we will have the structure it like this. Here's the benzene ring, and here's the R1 group, R2 group, NH, and double bond over here plus ammonia. So this is the Fischer synthesis of indoles. I hope it's clear to you. Now there are few key features, like few key steps in this particular reaction. The first step over here, you need to understand how the amine comes to this form, right? It's a pretty much very fundamental reaction. I hope you know it. If you have less experience on it, I highly recommend you to do more examples, do more practice with this particular reaction, because this is very important. You will find this reaction in many cases inside the organic chemistry. And the next thing is on this nitrogen, the hydrogen transfers, and in these last steps, I highly recommend you to follow this particular procedure and write it down on yourself for several times, so you will be more familiar with the reaction. So you need to understand each steps, and you must be able to propose this mechanism or give a certain clarification about these mechanisms in your exams. Okay, so I hope you get the idea about this Fischer synthesis and the synthesis of indoles. So in our next video, we will talk about the reactions of indoles. Now, if you have any questions, if you need any clarifications, please feel free to comment below. I will try my best to answer your questions. So we will meet on our next video.